rate of change of velocity. So A instantaneous bar should be equal to dv bar by dt. In general, whenever I say acceleration, it will be instantaneous acceleration only. Average acceleration was change in velocity by time taken. This is instantaneous acceleration. Rate of change of velocity, that one. Here again, the change in velocity means it can be change in only magnitude or only change in the direction or both. The rate of change of velocity is what we'll call instantaneous acceleration. At that instant, what is the acceleration? Okay, now we'll define the next quantity called as uniform accelerated motion. Uniform accelerated motion. So what do you mean by uniform accelerated motion? If acceleration of a body, like uniform velocity motion, if the velocity of a body remains constant during motion, it's said to be uniform velocity. Similarly, if an acceleration of body remains constant during motion, it's said to be uniform accelerated motion. So we'll define like this. If an acceleration of a body remains constant during motion, it is said to describe uniform accelerated motion. The acceleration must remain constant during motion. Then the body is said to be uniform accelerated motion. So how to express that uniform accelerated motion? So I do take help of the graphs. Okay, here. So the experimental curve if a body describes equal displacement in equal intervals of time, it is said to describe an uniform accelerated motion. This will not be there. I have to extend this black curve further. Straight line. Okay, I do have. So this is the time axis. This is the velocity axis. And this is time. T is in seconds. This is right time. Okay, let this be 2 seconds. 4, 6, 8. And let the speed of the particle, let it increase of this order, 30, 40. Now I can say that for every 2 seconds, the velocity will increase by 10 meters per second. So what do you mean by uniform accelerated motion? If a body produces equal change in velocity in equal intervals of time, it is said to be uniform accelerated. There's one more definition what will bring it. If a body produces equal change in velocity in equal intervals of time, it is said to be uniform accelerated motion. The body is said to describe uniform accelerated motion. I think you can see the particular equal intervals. So what are the equal intervals? You can see this. In first, like 2 seconds, the velocity will increase from 0 to 10. In next 2 seconds, again 10 to 20. So calculate this. Let's calculate this acceleration. Not average, it's instantaneous only. Change in velocity by time taken. So 20 minus 10 by 2 minus 0. 10 by 2. 5 meters per second. you calculate at any interval of time, the acceleration remain constant. So for uniform accelerated motion, so what we can write it as A instantaneous must be equal to A average. Already we have discussed for uniform velocity motion, the similar idea we can express here, but we are more bothered about instantaneous acceleration only. So if the acceleration of your body remains constant, you decide to describe uniform accelerated motion. So what is a very important part in uniform accelerated motion? If a body produces equal change in velocity, whether velocity increasing or decreasing, but change in velocity should be equal in equal intervals of time, then said to be uniform accelerated motion. Okay, there's one basic idea of uniform accelerated motion. Okay, now in uniform acceleration, we'll see that how that velocity, acceleration, times are related. So I'll